My name is Mostafa Heshmat. I am a quantity surveying master student in Nottingham Trent University. In my presentation, I'm going to talk about all the aspects of one of the revolutionary buildings in the world, the turning torso. These are the outlines of the presentation. The turning torso is located in Malmö, Sweden. It is the most aspiring building, the tallest and narrowest skyscraper in Sweden as well. It's not just the tallest building in Sweden, it's the tallest building in the Scandinavian area. It gave Malmö a new touristic destination. Anyone is really impressed when looking at such unusual and twisted landmark. Now I'm going to talk about the general background of the project. This will cover the story behind the torso concept, some surprising facts, the location and awards. The torso's idea surfaced when Malmö was undergoing a renaissance, with the local politicians' vision for something that would make an impact not just in Sweden but around the world. The building was constructed to replace Malmö's landmark, the 130-meter-high Kokoskarant crane, after it was demolished, to restore the Malmö skyline. Malmö's future depends on the success of turning this idea into reality, to redevelop Malmö's western harbor near the Øresund Bridge, which connects Sweden and Denmark. Another surprising fact is that the project was almost not done, as Kaltavra, the architect of the building, was worried that a city such as Malmö, a small city with abandoned shipyard, was not ready for such a luxurious project. But after the new bridge between Sweden and Denmark was constructed, Copenhagen was just 8-kilometer drive away from Malmö, and Torso just being across the bridge would turn Malmö into a new touristic destination. It changed the skyline of the city. These are some interesting facts about the project. The Torso holds the highest apartments in Europe. Another fact, even before the rent for the apartments in Turning Torso was announced, around 1,300 people had expressed their interest in renting an apartment. Till this day, 3 or 4 new applicants turn up each day for renting an apartment. The Torso is a pioneer that inspired a new wave of twisting buildings in the world, such as Caen Tower in Dubai and Torres de Caltrava in Valencia, and much more twisting buildings. The building is located in the western harbor of Malmö, beside the Ribersborg beach, just across the connecting bridge between Sweden and Denmark. On a clear day, the building would be visible from Copenhagen in Denmark, in the distance across the Øresund. This inspirational project has received several prestigious awards. In 2015, it received the 10-year award from the Council on Tall Buildings and Urban Habitat. Moreover, the FIB 2006 Award for Outstanding Concrete Structures and the MIPIM Award, and much more awards. Section number 3 is the building description. This section will cover some general information, the design and concept of the building, the material used for the construction, the facade of the building, the finishing material used in the torso, and the cost of such mega project. These are some general information about the building. The owner and developer is HSB, which is an association for housing in Sweden. The architect and the structural engineer is the company of Santiago Caltavra, Architects and Engineers. The electromechanical engineer is the Sustainable Engineering and Design Company. The main contractor of the project is NCC, one of Sweden's top contractors. The interior designer is Samarka Architecture and Design. The total height of the torso roof is 190 meters. The height of each floor is 3.18 meters. The excavation and construction started officially in 14th of February 2001, and the construction ended officially and the building was opened on the 27th of August 2005. The designer and mastermind behind this masterpiece is Santiago Caltavra. He is one of the most fascinating architects of our time, and he is responsible for a number of fascinating projects all over the world, such as the City of Arts and Science in Valencia, the World Trade Center Transportation Hub in New York City, and the Olympic Sports Complex in Athens. The building's Spanish architect Santiago Caltavra was inspired by a white marble sculpture called Twisting Torso that explores the human body in motion, as it can twist as far as it can while staying directly upright. This sculpture is in fact his own piece of art. The tower is divided into 9 segments of 5-story pentagons that are stacked one above the other, with one floor recessed between every two adjacent cubes. The topmost segment has an angle of 90 degrees clockwise if you compare it with the ground floor. In another meaning, the tower twists 90 degrees from top to bottom, and that's why it was named the turning torso. The building is situated in the middle of black granite reflecting pool with two sculptures that were designed by Caltavra as well. During construction, 44,000 tons of steel reinforcement were used. Moreover, 25,000 cubic meters of concrete, 900 metric tons of steel in spine and ribs, and glass and recyclable aluminum for the facade. And now I'm going to talk about the facade of the project. The total facade area is 2,000 meters square. Its color is white, and it was chosen to give it a noticeable and stunning appearance from far away. The facade system is curtain wall that is made out of 2,800 curved panels and 2,250 flat windows in total. The facade is curved aluminum panels with windows that have an angle between 0 and 7 degrees, either inwards on the western facade or outwards on the eastern facade in order to follow the twist of the building. Not everybody knows that, but there are quite some windows that are broken every year. When the torso sways, it stresses the glass in the windows, and some of them can't handle the movement, they crack and get broken. The torso is furnished to a high and modern specifications. Entrance halls featured polished limestone floors. The same stone is also used on window sills. The exterior of the turning torso features a black granite reflecting pool and a granite entrance path. Granite is also used in some places within the building, notably in the lobby. Tiled bathrooms are fitted with granite surfaces and underfloor heating. The kitchen units are specially designed from light stained oak or glossy white laminate to accompany the kitchen appliances such as the white washing machines. The apartment doors and wardrobes are made of white stained oak as well. Customized version of corridor microacoustic ceilings are installed for the spiral-shaped corridors leading from the entrance hall to the car park, as well as the offices in the building. Every single ceiling tile used in corridor was custom made in order to follow the curving movement of the corridor. Semi-transparent curtains along the circular ceiling serve to create a room within a room. The carpet used also takes up the circular form. A turquoise color with shimmer effect has been chosen for the walls of the living room. The ceiling of the bedroom is leafy roof in silver that gives a metallic effect. The architect Santiago Caltavra made a mistake and calculated the wrong amount of reinforcing iron to use. 44,000 tons of reinforcing iron were used instead of what was planned, 1,850 tons. This means a huge increase in the total cost, and that caused that the construction time was increased by one full year. The outside steel frame has also had its cost increase due to a conflict with the supplier. The total cost was increased from the planned 80.5 million US dollars to an actual total of $286.5 million, as the building turned out to be more complicated than planned. Section number 4 covers the structure analysis of the building, as well as the foundation of the torso and the superstructure. The central core is supported by a foundation slab that is made of 30 meters in diameter and 7 meters thickness, which was poured in 3 continuous days. The tower rests on piles driven into a foundation that sits directly on the limestone bedrock. The piles were driven 50 meters into the ground and further 3 meters into the limestone bedrock by an enormous vibrating sheeting machine. This type of foundation slabs were used to support the building and avoid any unexpected bending or swaying. And now I'm going to talk about the superstructure. First, the structural slab. Slab forms are fitted around the core. The forms of the structural slab are triangular shape and fitted together like a slice of pie to form an entire floor. The corner of each floor is concrete column supported by a pile foundation. The forms of each floor rotates 1.6 degrees in order to create the characteristic twist of the building. The concrete core is the main load-bearing structure of the building, with an inner diameter of 10.6 meter and walls 2.5 thick on the ground floor, and decreases gradually till it reaches 0.4 meter at the highest level. The core is shaped like a concrete pipe. The core houses the lift shafts and staircases inside of it. A circular hallway rings around the central core to provide a walkway from the lifts to each flat. The concrete spine twists up the torso, part of the support structure that protects the 9 cubes from the wind loads. The concrete spine is constructed floor by floor. Every section must fit exactly with the one below it, and it's tilted slightly at a precise angle. This picture shows the main superstructure elements of the turning torso. The torso's exoskeleton wraps around the torso, which is effectively a white steel truss erected on the outside of the building with the same clockwise rotation as the tower itself. It is critical for the torso support. While the spine column takes perimeter vertical loads, the exoskeleton around it provides it with wind resistance and dampens the building's vibration, acting as the load backbone from the wind. The exoskeleton consists of a spine column at the corner of each floor, with diameter up to 90 cm, fixed to the tower between each module, mainly with horizontal and diagonal tubes. These tubes reach back to 4.5-ton steel anchorages embedded in shear walls at the building's back corners. The steel support transfers shear forces to the supporting concrete core. As you can see from this picture, this is how the load is transferred. At picture number 1, the load transfers from the exoskeleton to the horizontal and diagonal supports, to the core, and then to the foundation. Now I'm going to talk about the construction process and how it was done exactly. During construction, crew had to work 80 hours a week to stay on schedule and budget, as lots of days were lost due to extreme weather conditions, as the conditions were very severe. The wind speed was 72 km per hour and temperature below freezing point on top floors. The plan is to construct one floor per week. The construction couldn't be done without the help of the automatic climbing structure. This structure shapes the building floor by floor, and it is the muscle that made everything possible. It was anchored on 12 fixing points with a concrete boom installed on its own climbing scaffold that uses 4 fixing points in the core. A Putzmeister device on the ground floor pumps concrete to the higher levels with power of 1 ton per second. The outer floors are built using a temporary platform called the table floor. The table forms are tied to the concrete core and the legs are screwed tight to the floor below it to fix it in place. All the table form sections are connected together to provide a base for the rebars and concrete. After concrete is dry, the automatic climbing structure moves to the upper floor. Before the table slabs are moved to be used in the next floor, they are inspected on the ground floor. This process may sound simple, but in such a massive project, it was very challenging. All the project sections were prefabricated and installed in place. The reinforcing iron bars are made ready on the ground in a building nearby. The staircases as well of each floor is precasted and installed in place from opening from top to the bottom. 2 cranes were used to move the table forms for maintenance and construction. The construction process was done as follows. First, the table forms are added, and when they are completed, the rebars are installed in place. Then, the concrete is poured. After the pouring of concrete and it's dry, the automatic climbing structure climbs to the next floor to continue the same process. Floor by floor, this is done until the whole building was constructed. The final section of the presentation is the function of the building. This section will cover the uses of the building, the services that the building provides, the sustainability of the building, and finally, the safety. The main main usage of the torso is for rental apartments and conference offices. Houses, top quality apartments, offices, and conference rooms. It consists of 147 rental apartments on the floor 14 to 50, ranging from one bedroom, 45 meter square units, to 190 meter square units. Not all apartments are equal in dimension because of the floor space changing due to the size of the core walls. So the ground floor has 30-70 meter square of usable space, while the top floor has 430 meter square. All the apartments have unique layouts depending on their position in the building. The living rooms are large and open, and often with views in two directions. On the seventh floor, there's a room for celebration. The room can take up to 50 guests for dinners. There's a gym, sauna, and jacuzzi at the 43rd floor. Each apartment has its own space in the wine cellar. Close to the wine cellar, there's a cozy little room for tasting wine. The 43rd and 44th floor, with magnificent 360-degree view, will have conference halls. The torso offers a wide range of different services. There are 5 high-speed lifts in the core of the building. They travel at 5 meters per second, so it only takes 58 seconds to go from ground level to the 54th floor. 3 of those lifts are used for the residential apartments, while 2 are used for the commercial areas. A separate parking block is used for residential and business tenants and can be accessed by a private tunnel. The heating system of the building is powered by a utility of SkyDraft system and accompanied by 100% locally renewable. The 2 lower cubes of the torso contain offices and conference rooms that have separate heating and cooling and IT systems. There is no extra charge for cleaning the window as it's included in the rent of the apartment. Sweden has perhaps the most far-reaching environmental legislation in Europe. 100% of the energy consumed in the building supplying the tower as electricity and heating is zero. This is obtained from a variety of sources, including wind power, biogas, and solar sources. The torso also tries to make it easier for residents to be environmentally friendly. Residents can make informed decisions regarding their energy consumption with electricity consumption meters installed in each unit, allowing the residents to control their own energy costs and thereby their impact on the environment. Moreover, the torso plays its part with organic waste. In the kitchen, there is waste disposal unit in every apartment for guarding organic waste and transported to Malmo biogas plant, where it produces biogas. Moreover, non-recyclable waste is collected in garbage chute at the basement. The whole building, including the exterior skin, is lit artificially by golden dragon lid, which is environmentally friendly. The trailing torso consists of top safety measures. All security systems have independent reservoir power supplies and emergency lighting. One of the lifts has its emergency electricity supply for using by safety personnel during evacuation. Sprinklers, fire alarm, and smoke detector and fire gas ventilation is installed in every room. The water supply of the sprinkler is double water supply system and has its own emergency electricity supply. Each floor in the apartment has its own fire cellar. It has fire rating of 2 hours. Literally speaking, the torso is consisted of 6 buildings on top of each other. All the rooms have secure windows and it's impossible to open them for security measures. Cameras for surveillance is everywhere and monitors different parts of the building in order to get security all over the building. Thank you for listening and hope you enjoyed it.